What the heck is up, YouTube and or Twitch? We're here with day 5 of Advent of Code. We're going to be coding very beginner level Python style with loads of explanations, loads of sort of tutorial type stuff, but hopefully also collecting all of these star coins on the Advent of Code challenge. Those of you that don't know, Advent of Code is available at adventofcode.com. It's in the Twitch chat now. It's a set of sort of 25 Christmas themed coding challenges that are really good if you're sort of 6 to 10 hours into learning a language and you're not really sure what big projects to start working on or where to learn next, but you've got those fundamentals down. Even though you might have those fundamentals down, I'm going to try and readdress them each day and make sure that there's almost nothing that's not explained. I'm sure I'll skip over that, as any expert will do. But yeah, have I missed anything else? It'll all be available on YouTube, it'll be available on Twitch, and I'm giving myself 1 hour to do them each day. So let's just jump straight into it. Let's get coding. I'm running on less than 5 hours of sleep, so this might be the one we don't get very far with, but let's see how we do. So, day 5, binary boarding. You board your plane only to discover a new problem. You dropped your boarding pass. Pass. You aren't sure which seat is yours, and all of the flight attendants are busy with the flood of people that suddenly made it through passport control. You write a quick program to use your phone's camera to scan all of the nearby boarding passes, your puzzle input. Perhaps you can find your seat through the process of elimination. Instead of zones or groups... Are they going to define what zones and groups are? Oh, I'm not watching that. This airline uses binary space partitioning to seat people. A seat might be specified like F, B, F, B, B, F, F, R, L, R, where F means front, B means back, L means left, and right means right. The first 7 characters will either be F or B. These specify exactly one of the 128 rows on the plane, numbered 0 through 127. Each letter tells you which half of a region the given seat is in. Start with the whole list of rows. The first letter indicates whether the seat is in the front or back. The next indicates which half of that region. So it's basically a binary string here. So we can convert this number into denary and it should give us our row. Now I'm going to go into that in more detail when we start coding it. But we should be okay dealing with that. The next letter indicates which half of that region the seat is in, and so on until you're left with exactly one row. For example, look at the first characters, the whole range of rows 0 to 127. F means, yeah, that's fine. This is the definition of binary numbers to me. It means the up half, yeah. Okay. The last 3 characters will either be left or right. These specify exactly one of the 8 columns of seats on the plane, numbered 0 through 7, the same process as above. Scuffed mic. What's going on with the mic? Is it clipping out? I can turn it down a little bit. I don't know if you're pranking me. For example, consider last. Yeah, so I think we'll do some sort of visualizations here while we're coding it, just to make it a bit obvious. Decoding reveals that it is the seat row, blah blah blah. Every seat has a unique seat ID. Multiply the row by 8, then add the column. That gives us our seat IDs. Here are some example boarding passes. And look through a list of boarding passes. What is the highest seat ID on a boarding pass? Okay. So we're not even gonna find our seat ID, we're just gonna look for the highest. And let's double check what that input actually looks like as well. Oh, that's a nice looking input. Okay, so let's just make sure I also need to return the highest seat. I think I'll probably forget about this, so I'm gonna leave this as a comment too. And in our example, this is our test case. Yeah, it reads pretty nasty. Like, especially if you've not done anything binary before, as I assume almost every programmer that begins programming has never sort of experienced the world of binary stuff. It's not going to be easy to think, but I'll go through the maths as we get to it, and we can break it down. Okay, so to start with, I'm gonna store this. Oh yeah. So as usual, I've just taken some interesting information because there's loads of stuff in there that's nonsense, loads of context that we don't actually care about. So I've taken some sort of prompting comments, and in REPL.it, let me share my code as well, sorry. In REPL.it, you can do control / or command / and that will comment or uncomment in whatever language you're in. We're going to take our test input and we're going to store that as a string. So what we're doing here is we have a variable name. We're using equals as an assignment, so we can kind of read this as, you know, this value is assigned to this name. So we're going to have some string, which is denoted by these quotes, and we're going to assign it to the variable name. So we've got test, and now if we run that by clicking this play button up here, we can access that test variable. So we can do stuff like test plus test, and it'll concatenate it all together, not that we need to do that. Right, so we don't actually know how many, oh no, we do know how many seats there are on this plane as well, because we know that there are 128 rows, and there are 8 potential seats. Rows, 8 columns. So we could actually print out a visualization of the plane, which I feel like might help us in the second half, and I've seen some really cool, just looking on the subreddit yesterday when I couldn't finish the challenge, there were some really nice sort of like colourful visualizations of some of the stuff, and I think that really helped with day 3 of that sort of slope tobogganing thing. I think that one's officially been the hardest one so far with the least completions. And I think our visualization there saved us a lot. So I might have a look at visualizing the plane as well. Because that, to me, that can just be, you know, a set of, how could I write that quickly? We could have a sort of, you know, a plain object that's going to be a list, and then empty row object, which is going to be a list of empty seats, which I'm going to denote with a circle. 5, 6, 7, 8, and then I'm going to do for x in range 1 to 8 colon, I'm going to add this to our plain object append append empty row, and then now if I print out our plane, that looks terrible. Visualize the plane for row in plane print row. That looks okay. I'm going to join it just because I want to. Oh, this doesn't have join? I don't believe it. This join Python. Weird. So is that a string function? String.join row. Okay, so here's our visualization of the plane. Let's get a, can we get the index as well? Sorry, I'm just trying to visualize the plane for some reason. Does this work? Let's not do that for now. So I've got something that's going to let me visualize my plane. I don't know why I've done that, but I think it might come in useful. You know what, it's not going to come in useful. Let's not worry about this for now. Let's just focus on what we're supposed to actually do. So we've got this test case. We're going to need to split it into our 2 sort of row and column strings. So I can do row column equals, and we want to split the first 2. So I want to get these first 7 characters, which are always going to refer to the row. So I'm going to say test, and we're going to use slice notation. So using this colon, we'll get the whole thing. print row. So that's the whole thing. We don't want the whole thing though. We don't want the last 3 characters. So I can do count up to -3. Did I miss one there? That looks about right. I'm just going to check. Slicing up to, no, okay. So we want to count up to -3. So what this will do is it'll set the counter to be 3 positions from the end. Oops, to here. And it'll split that first half of the string. So in the same light, we can get our column using test and counting up to -3. And that should give us our rows and columns. So what we're doing here, Rattles, is we have all of the tickets on a plane are described like this, with a string denoting basically in binary whether it's the front or back half of the plane. So F for front, so it would refer to 0 to 64, B for back, and it'll continue like that, and then right left is for an 8-digit row, not 8-digit row, 8 possible seats in a row. So we've got our columns, we've got our rows. I'm probably just going to convert them to binary, since there's not much point in me keeping them like this. So I can call, let's write a function that's going to replace things. So def binary replacer, and it's going to take a 0 and a 1. So those are going to be characters that we replace with 0 or 1. I'm going to have to make sure I get this right. Then we're going to return, oh, I need the string as well, sorry. Return input. I'm going to do return input dot replace. Now I think this takes, so if it's front, it's 0. Yes. So I think this takes like 1 string that we're going to replace, so that will be our 0, and then replace it with a character 0. So this 0 in the row string, for example, is going to be front, or F. So let's check that works. Binary replacer test. 0 is the front, B is the back, and let's wrap that in a print just so we can see what's going on here. So it should replace all our fronts with 0s, which it does. We don't actually need the whole thing replaced, we're just doing the rows for now. Then I can chain, so I can just call the next function again, 1 and 1. Cool, so now we've got 0s replacing our Fs, 1's replacing our Bs, and 0's replacing our Fs, and we can do the same thing. So we want to overwrite our row with this, row equals, and column equals. Handy tip, most editors, if you double click something, it'll select the whole word, and Control D will find other occurrences. You can type 2 different things at once, so just replace row and row with column and column. Here we need left and right. How do I do this correctly? So right is our 1. So we have left and right. So now if we print those, we can print, I don't even need to type print, I can type column here, 101, that looks good. And that would be 5, which is column 5, cool, all good. Right, so let's talk about binary numbers real quick, because I'm aware some people might watch this and have no idea what I'm talking about. So what happens is, when we see a number in what's called denary, or you might have heard of it as base 10, so you might have a number, for example, 101. So I'm saying a lot of weird words, binary, denary, all this. We don't need to worry about this. Basically, if you're a normal person, the only type of number you've probably ever really seen is a denary number. And all that means is that each of these units represents a multiple of 10s. So we could write this 101 as, so for this bit here, 1 times 10 to the 0. confusing. So now we need to go look at this. So any number to the power of 0 is always 1. We can kind of show this with... That's enough to know for now. Let me just see if I can remember how to do this. So if we have like... There's a law of indices, for example. So if you do like 2 squared times 2 squared, you get... That's 4 times 4, which is equal to 16. So we can actually write 16 as a power of 2, and that power would be 2 to the power of 4. And so there's actually a law of indices here, where if you take any two numbers, x to the power of something, let's call it x to the power of a times x to the power of b, that will always equal x to the power of a plus b. I think that's correct. So alternatively, there's another form of this where we have... Actually, no, this is enough to use. So we could use 2 to the power of a half and 2 to the power of 2. So these are equal to... what is it? Root 2 and 4. And if we multiply root 2 and 4 together, that's the same as doing 2 squared times, you know what, I've blundered this, haven't I? It's not 2 to the half. I want to say 2 to the minus, I want to say 2 to the minus 2, I think. So 2 to the 2 is 4. 2 to the minus 2 is 1 over 4. So if we use this rule here, 2 to the 0 is equal to 4 times a quarter, which is 1. And that's going to be true no matter what those numbers are. So that's why something to the power of 0 is always 1. Maybe too much detail there. But for now, let's just take that fact. So anything times anything to the power of 0 is going to be 1. Right. So this next column is what we would call, if we were kids, right, we might say this is the ones column, and we might say this is the tens column. This is kind of how it's taught in schools. So what this position actually means is 0 times 10 to the power of 1, which is 0 times 10, which is 0. So we have 0 tens. And then finally for this part, we're saying 1 times 10 to the 2, which is equal to 1 times 100, which is 100. So this is the way that our numerical system works. It even works if we continue past the other side. So this one can be worth times 10 to the minus 1, and it sort of continues down that way. But we don't need to worry about that for now. We're not going to go into what decimal stuff actually is. So if instead we look at this as a binary number, the only part of this that changes is that these 10s become 2s. So we can treat this exactly the same. So let's say we have I'm going to delete everything. So let's say over here this is our denary number, denary or decimal, and over here we've got our binary number. So 101 in denary and 101 in binary are potentially different numbers. And what this means in denary is that we're going to take this part here. How can I write this in a nice way? So we're going to look at this first character. So that means 1 times 10 to the 0, which equals 1. And over here it means 1 times 2 to the 0, which also equals 1. 2 to the power of 0 is always 1. 10 to the power of 0 is always 1. Then we're going to look at the second column. So this means 0 times 10 to the 1, which equals 0. And same here, 0 times 2 to the 1, which would be 0 times 2, but that's equal to 0. And then finally, we've got 1 times 10 to the 2, which is equal to 100. Then we can add all these numbers up, and that gives us 101 in denary. Over here, we do 1 times 2 to the power of 2, Now 2 to the power of 2 is 2 times 2, which is 4. So 1 times 2 to the power of 2 is 4. So if we add all of this up, we get 5. So even though we've sort of got the same number, because they're represented in different numerical systems here, we've got 100 and... I didn't even add up 101 correctly. I do mean 101, yeah. Hopefully I said 101. So yeah, the same number in two different numerical systems is basically not the same number. So what we're doing in this case is we're actually going to be using binary to represent these right, lefts. So if we've got our number, is it right, left, right, we're going to do the same thing, except I've already replaced, so left is a 0. So I'm basically converting this to that binary number 101, and then doing the same thing. What's this times 1? What's this times 2? What's this times 4? To get the column 5, which is the whole question, basically. So I'm sure now that I have a binary number, I can probably just use a binary number converter that will handle this next bit for me. So def get denary, given a binary number, and I'm sure this is so common that there must already be, Python convert binary to denary. There might even be a denary function, bin function to convert a decimal value, int function to convert to binary. I don't know if that'll work because it's not. I'm just thinking about like leading zeros, but we might be okay here. So I'm slightly concerned if, for example, we had the number 0, 1, 0. That 0 at the start is important. It won't let that be an integer. But if I convert it to an integer, what will it do? It'll complain. So how does... Yeah, so this case isn't quite what I need. I wonder if I can cast it to a binary first. So instead of... So bin will convert... No, it won't. I guess I don't need to worry about leading zeros, because if there's a leading 0, it's not useful information anyway. So let's see if we can get away with not worrying about that. Yeah, that makes sense. So how do they know that's a binary number? Do I have to convert it to binary first? That's not useful. Int. Oh, I can set it to base 2. Enter number into binary. Okay, so the int actually takes a... It can take a case over here. So we can put 101 and tell it that it's what's called case 2 or binary. Sorry, base 2. Oh gosh, lack of sleep is showing. Can't convert non-string, so let's do this as a string, which it will be 5. Okay, cool. So that's all we need to return. Int binary number 2. So now we can do print row and do get denary row, and then here do the same thing but with columns instead. So row column, row 44, is that correct? Yes, row 44, column 5, and then we just need to return the row multiplied by 8 plus 5. So print, you need to store these. Row equals get denary row. I'm overriding my variables quite a lot at the moment, so I'm expecting that to go wrong somewhere, but let's see how far we get. Row, column, and then that's row times 8 plus column. And we just want to print that out. Do some maths. 357, which is the answer here. And then we need to look through and find the highest ID. So let's write a quick get ID from row column. And let's just let this do our return row times 8 plus column. So I'm doing a lot of stuff here. I haven't explained what functions are. So we've got this def keyword, short for define in Python. We write a function name, and then we've got parameters that can come here, comma separated. And then we do a colon, so we do this after every if statement, for loop, anything like that. And then we have a keyword return that lets us pass a value back out when the function is called, like it is here. So we've got get ID row column, so we can do get ID row column. How are we going to prepare this? So we've assumed that we can read in our, kind of got everything here actually. So this is ready to be converted to a function. If we move some of this about, so that can go there. Keep these functions at the top, and now we've got this. So this will be our input, so def calculate ID. That's not great, but that's going to take a input, and then we're going to do all of this indented. I'm going to replace test with input, split string into row and column part. Then we're going to convert to binary string, convert binary to denary, and then print answer, print answer, print ID. It's not an answer really, row and column, and print ID. We don't even call the function now, so we can get rid of this test case now, and we can just keep this as a string that we pass in. Calculate ID, and we get 357. Cool. So next we need to add in something. Let's read in from a text file so we can prepare to use this input, inputs.txt, and let's just do this so we can see if this works. So we've got, same as I Google every day, read in file Python line by line. I love this Stack Overflow. It's always got what I need. Okay, so now we can do, with our inputs open, .txt, our lines here, and then we can iterate over those lines for line in, let's say for ID in lines, calculate, and we're going to pass in ID. ID's not quite right. Just say for line for now. And that's going to take line, and then it will return our values here. So we need to keep track of a largest value. So a nice easy pattern here is to pick a small value. So we could say largest so far equals 0. And then here we can say if calculate line, calculate ID is greater than largest so far, then we want to replace largest so far with this new value. In fact, let's do, so ID equals calculate ID line, then we can say if ID is greater than largest so far, which saves us from calculating it twice. Then we're going to replace it, so we can say largest so far is equal to ID. So if we run this here, we should still see our prints. But okay, 42, if ID is greater than largest so far, I'm guessing largest so far is still a string, so we can wrap it in this int function, and that will convert it to a whole number. No, it won't. What have I done here? Largest so far 0. Greater than is not supported between a none type and an int, because my function doesn't return my getID here as it should. Return getID. That means we might not need this in anyway. Cool. And then the largest so far we don't print out. Print answer comma largest so far. And our answer is 820, which looks correct to me. I mean, it doesn't say it's correct, but I'm using my brain to calculate that 820 is the largest answer so far. So now we can use all these strings instead. We can give that a go. Okay, we get 855. So I'm guessing now it might want us to, whoa, that's not 855. Guessing now for the next step it might want us to find our seat, I assume. So maybe there's only one empty seat on the plane now. I'm gonna submit it. Oh my god. That's the right answer, everybody. We did it. I can't believe it. That's another star coin. We're one step closer. We're one step closer to going on holiday. I can't believe it. It's been an awful year. And we're finally going on holiday. We're getting so close. We only need, what is it, 41 more stars now. Let's see if we can get one more star. Let's keep this going. Okay, we still got half an hour left anyway, and I think this is going to say, you know, find the missing seat on the plane, so I'm not too worried about that. I don't have a video. I play it when I get it wrong, actually. I just get very defeated and sad very quickly. Okay, part 2. Ding! The fasten seatbelt signs have turned on. Time to find your seat. It's a completely full flight, so your seat should be the only one missing a boarding pass in my list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back, though. The seats with IDs +1 and -1 from mine will be in my list. What? Okay. It seems odd. Surely we could just find, like, the lowest. Like, if I just print out all the values, the lowest will... No, that's not safe. I guess... So if we imagine the plane, so there's going to be loads of seats, but I'm imagining something like at the front and the back of the plane there might be just random seats missing. I don't know. This is where that visualization would have been really useful, so maybe I'll bring that back. Is that silly? Let's see. We've also got all these unique IDs, so if we sort them, we could be looking for the... Man, this feels strange, but okay, let's do... So instead of just storing largest so far, we want to store seats taken. And each time one of those seat IDs comes back, I'm going to put them in the list. So we've got an ID here, so I'm going to do seats taken.append ID. And then here I can print, bad idea, but I'm going to print seats taken, and I'm going to do seats taken. Yeah. So we can sort that. Is there a sort function built in? Maybe. I mean, definitely, but I don't know if that's the right one. Might be a dot sort on a list instead. So let's try seats taken dot sort. Okay. Sort a list Python. I did that. Is it because they're strings? Int. So because they're strings, it might not know a good way of sorting them. Oh no, I've done this before. It's because the sort function sorts the list in place, so it doesn't actually return something. So we call sort like this. And then seats taken should be sorted if we print it out now. Cool, that looks good. So I can get rid of these ints maybe. Yeah, Okay, so we've got 855 here. We're looking for the gaps. It doesn't look like gaps in the back of the plane, but obviously I'm just visually checking. So 47, 45. I don't see any gaps. 32, 29. Don't see any gaps at the end, but let's check the start. So look, it says the seats up to 81 are missing. But then after that, you know what, it looks to me like there's just some missing rows. So really I could just like loop over this entire list, but there's going to be a missing value. So what can I do here? Check if the next value in the list is equal to the previous value of the list and print it out if it isn't. For seat in seats taken, there's going to be one that's not one ahead of the next one, right? So if I print seat, but I also want to store the previous seat. I'm going to say equals to 0, and then each time I'm going to say if seat, if seat equals previous seat plus 1, no, we want it to not equal that. If it isn't equal to that, then we want to print the seat. Need to indent there. So we haven't used an if statement yet today. Yes, we have. So if kind of and for are like our def from before. So it's a keyword, end it with a colon, indent to run code underneath it. This should probably print so this first one obviously isn't in sequence, but then otherwise it should print our answer, I hope. Oh, let me clear that. I was like, that's not what I expect. Right, we can stop printing all the seats out for now. So we've got, oh dear, if seat is not. Is that because they're integers? Let's print them both. So prev seat, just so we can see what we're looking at. I'm not setting prev seat. Thank you very much, Rettles. This is nice. I should always have you guys watch me. Yeah, there we go. So that makes very clear, but as Rettel said in the chat, I'm not setting prev seat anywhere. I need to do it inside each of these. So prev seat, after I do my logic, I need to say the previous seat is now equal to the current seat. So when we get to the next part of the loop, it's updated. So now we should see, hey, that looks suspicious, 553 and 551. So if I bring this outside of the loop, oh, it prints 81 as well, which is why I said it would. You can see there, we've got all these numbers that are one less than the next one, and what was it, 553 was my seat. So if we get to around here, you see there's a gap there, 553, 553. So we're missing 552, it looks like. And we can confirm that by reprinting this anyway and manually checking. So let's do that. So there should be 552 missing in here, and we can just check that. 551, 553. So 552 is our missing seat. Is that even what we were asked? What were we asked? 552. Oh my god, I can't believe it. We've done it again. We had such a hard day yesterday, and then today we finished both the tasks in 40 minutes. Fantastic. I cannot believe it. Good work, everybody. Thanks for the help in chat. Whew! I'm so glad I know what binary numbers are, because that would have been a nightmare if I didn't. But yeah, good stuff. Fantastic help, everybody. And yeah, thanks. It's a Saturday, so I'm surprised I managed to get this done, but yeah, should be one tomorrow on Sunday. And let's keep this train going. Let's finish the advent of code together as a team. Alright. Thanks for watching, everybody. throw to that. Thanks for watching the screen. See you later.